Hello, hello. In a previous example, we examined a hypothesis test for comparison of two fitness programs. In this follow-up video, we're going to examine the confidence interval for the difference in the means for the fitness programs. So just to review a bit, here was the original problem when we looked at the hypothesis test. 40 women were randomly assigned to an old program, program 1. 40 women were randomly assigned to a new program, program 2. They each spent 18 weeks in the two fitness programs, after which time each group was giving a fitness test that yields a score between 0 and 100. We already decided we had two groups, 40 women assigned to program 1, 40 women, again, randomly assigned to program 2. The selection of the women for the two programs is unrelated, so the groups are independent. And the question of interest, do the data provide evidence that the mean fitness score for all those using the new program, program 1, is greater than that of the old program? To answer that question, we conducted a hypothesis test. We allowed mu1 or group 1 to be the mean fitness score for all women using program 1. mu2 to be the mean fitness score for all women using program 2. The hypothesis test were that mu1 and mu2 are equal. There's no difference. That's what the skeptic would say. The alternative, what we're interested in, is whether the new program, program 2, produces a greater test score. So we'd say that the scores for group 1 are less than the scores for group 2. And again, the computer turns all of these things into differences. If mu1 is less than mu2, then mu1 minus mu2 is less than 0. As you see, that's the way the computer looks at it right there. Now, we conducted a hypothesis test. We obtained a sample difference. The sample difference is the difference in sample means of negative 9.15, a p-value of 0.0014, and that allowed us to reach our conclusion. And our conclusion was, since the p-value was 0.0014, which is less than 0.05, we reject H0. And thus, there's evidence that the mean fitness score for all women using program 2 is greater than the mean fitness score for all women using program 1. The follow-up question, which is what leads us to the confidence interval, is essentially how much better. Program 2 seems to improve fitness scores on average as compared to program 1. By how much does the program improve the fitness scores? The test only says that program 2 produces a greater score. It doesn't tell you by how much. It might be a point, it might be 100, it might be 10 points. So the statistical version of this follow-up question is we're going to estimate with 95% confidence the difference in, and let me get a different color pen, the difference in the mean scores of program 2 as compared to program 1. Okay, so we're going to look at the mean, the difference in the mean scores of program 2 as compared to program 1. That's what we're interested in estimating. In other words, mu1 minus mu2, that's the parameter of interest. Okay, so that is going to be a confidence interval. And a two-sample, independent samples confidence interval is given by the confidence interval formula. I'm not going to ask you to calculate all of this by hand, but I want you to know what the pieces are, so I think it helps you to sort of think about what this is and why it works. What we do is we start out with, and here's our confidence interval formula, x1 bar minus x2 bar is the difference in the sample means. From these hypothesis test results, that is your sample difference. The t critical value is something that we get from the t confidence table. Notice the degrees of freedom for an independent samples test is often fractional, 77.08. So you say, well, what's the closest number I can come up with? That is 77. But on our T confidence table, it says that anything greater than 70 and 95% confidence, in this case you would use a critical value of 1.994. Lastly, this square root part of our formula is called the standard error, and that standard error is also given in the hypothesis table. So we have all the pieces of this confidence interval, and we can easily calculate it now. Using the formula, the sample difference, or the difference in the sample means, is negative 9.15, plus or minus the t critical value, 1.994, times the standard error, which is the whole portion of the square root, 2.96. Remember that this is a multiplication right here, so do the multiplication before the addition and subtraction, and when you do that math, you get that the difference in the sample means, which is, or the population means, which is what I'm estimating, is between negative 15.05 and negative 3.248. And this is estimating, remember this is estimating from our hypothesis test, mu1 minus mu2, or the test scores for program 1 minus the mean of the test scores for program 2. And that leads us to our conclusion. The conclusion, we are 95% confident that the difference between the mean fitness score for all women using program 1 and the mean score for all women using program 2, where we took program 1 minus program 2, is between negative 15.052 and negative 3.248. So in other words, now that, remember, that is program 1 minus program 2. They're negative. So how can you get a negative score? Only if program 2 is greater. So in other words, what this interval is telling us, since the difference program 1 minus 2 is between negative 15 and about negative 3, we can say that program 2 fitness scores are between about 3.248 and 15.052 points higher than those in program 1 on average.